We won't need our laptop around, or just, do you not have a booklet here today? No, that's okay, just share with Ashley for now. Okay, so first sort of 20, probably half hour, Michael. This is going to be pretty challenging, okay? So a bit different from our last 2 Friday afternoons. Right, we've just come in, have a lazy movie. Today we're doing the square of opposition. So I'm going to try and go through it nice and slowly. And it's a skill that we need for our logic test, okay? And so I'm just warning you that it will be a little bit challenging to encourage you to pay attention. Okay, so there's some encouragement there. So it is called the square of opposition, and I don't have my laptop's gone flat and things not working, so what I want you to remember is that any proposition that you, so what's a proposition? That's a statement that declares something. It can always be put in strict logical form, and it will be one of these 4 propositions. And we can symbolise them using shorthand as A, E, I, and O. So we call A universal affirmative because it says all S is P. Everything that's in this group is part of this group. Everything, it's universal. Okay? We have E, which is the universal negative. Everything in this group is not a part of this group. So it's universal about the subject again. And then we have particular. And particulars, where we're obviously not talking about the whole group, we're talking about either some of the group belonging to something or some of the group not belonging to something. So we've seen that before. We'll jump to the next slide, please. So here we have 4 propositions, and these are aren't listed in our book. We'll talk about them and then we'll go through the ones in our book. We're just identifying whether they're A, E, I, or O. So it's very simple here. Universal affirmative is of the form all S are P. So let's have a look there and try and find out which number is of the form all S are P. That would be number 3. It says all maths is that which is fun. Okay, so it's of the form all S is P. What about the universal negative? Where's there a universal negative? That's number 2, isn't it? It's of the form no S is P. The particular affirmative, so I. Some S is P. So some S is P. That's the first one. Some of this group belongs to the second group. And then the last one, the particular negative, some S are not P, corresponds with 4. So I think if you press it 4 times, it's going to bring up the 4 answers, I, E, A, and O. Okay, I'm going to leave that there for a sec, because what I want you to do, we're on page 25. Exercise 28, I just want you to go down the column and just next to each proposition, I want you to write whether it is A, E, I, or O. Okay, is it of the form all? Is it of the form some? Is it of the form no? Okay, so we're looking for the form, and then I'll read out the solutions for you in a moment. Answers here. I'm just going to cite out, just from the top downwards, the letters in the order they're in. So if you've got one that's wrong, just put a mark next to it so I can come and check with you. I've got A, E, I, O for question 1. Then it goes E, I, O, A. Then I've got I, O, A, E, and O, A, E, I. Okay, so maybe you've got full marks there. From what I looked, most people were sort of on the right track. Let's move on to the next slide. Okay, so we're good at identifying. This here is called the square of opposition. It's a tool, and we're going to use it. So we've got it up there on the board, and then I've got it down here so that I can point to it and demonstrate how we're going to use it. But what we're looking at is when we're given a proposition, what can we affirm about other propositions of that same form? So that's just it. Let's move on to the next slide and we'll get into some examples. Okay, so the first thing I want to point out to you is contradictories. These are the easiest ones. We have A, and then straight across the square of opposition we have O, okay? They are contradictory to one another, okay? Similarly, I and E contradict one another. Okay, so we're going to be very specific here, Caitlin, about the difference between contradictory, contrary, all right? Because maybe you use those words in common language in the same sense, but in logic they mean something very specific. So for it to be contradictory, if one is true, the other must be false. Okay, and then vice versa. If one is false, the other must be true. So, so here, you know, you've got the proposition, all lawyers are crooks, okay? If that is true, then it's contradictory. Okay, so the one straight across, that's how we find out what's its contradictory. O, which will be some lawyers are not crooks, is false. Okay, if A is true, O must be false. If O is true, A must be false. Okay, let's move on to the next slide. We've got an example here. Okay, determine the contradictory of the following propositions. Okay, so the first one we have is all bats are that which have wings. So we're going, is this an A proposition, an E proposition, an I proposition, or an O proposition? Who wants to tell me?
A.
This is A, okay? It's A, so its contradictory is going to be an O.
Some bats are not bats.
Excellent. So let's bring up the answer there, Mr. Glenn. Okay, so look how it maintains the same subject and predicate. The only thing that changes is the quantifier, so the word in front, and the copula in the middle has changed in this circumstance. Some is not. Okay, some people are that which like chicken. Okay, so that's of this form. Some S is P. Some S is P. And so the contradictory is the one straight across the square of opposition. That's going to be the no S is P. So let's bring up the answer there. No people are that which like chicken. If this is true, then this must be false. So that's what we mean by contradictory. Okay? So that's a nice easy one to begin with. Let's move on to contrary. Okay, contraries only occur between our universal propositions, so between A and E. Because they both can't be true, but they can both be false. Okay, so the example I've got, all lawyers are crooks, or no lawyers are crooks. Okay, both of them can't be true. Alright, but they could both be false. It could be true that only some lawyers are crooks, and it could be true that only some lawyers are not crooks. Okay, I think there's an exercise for this one. Let's have a look. So we've got the following proposition. All babies are that which dribble. So the question is, what is the contrary? If this is the proposition, what's its contrary?
Babies are not that which dribble.
All babies, no babies are that which dribble. Let's bring it up.
A is contrary to E, isn't it?
A is contrary to E, so the E proposition is no S is P. No babies are that which dribble. Okay, next question. What can we say about the contrary if the proposition is true? Okay, if A is true, it means E has to be false. So let's bring up that. Excellent. Okay, because they're contrary. Only one of them can be true. What about if A is false?
E can be true or false.
You're correct, Amy. E can be true or false. If we're told that it's false that all, what's that thing here? All babies dribble, we don't know whether it's true that no babies dribble. Okay, it could be that some do, and it could be that some don't. So it is unknown. There's not enough information to make a truth claim about it. Okay, next one. We might skip this example just to speed it up a bit. So this is no children liking pepper. Cool. All right, so then we've got subalternation, and that's going down here, okay, between E and O. So this one's reasonably easy to explain, and maybe I'll draw a diagram for this one, okay? If you have the statement, all lawyers are crooks, okay? All lawyers are crooks, okay? That's our proposition, and we're talking about all lawyers belonging to the group of crooks, all right? Obviously then the statement, some lawyers are crooks, is true because some lawyers are part of the group of all lawyers, okay? So if A is true, it subalternates to I. I must also be true. Okay, that's subalternation. So if A is true, then I is necessarily true. All right, but it, just careful with the last one, it only applies for truth, okay? So if A is false, it does not mean that I is false. We don't know the value of I, just given A is false. Okay, next one. So we have the proposition, all monkeys are that which like bananas. So this is an A proposition. All monkeys are that which like bananas. And so what is the subalternate? That's going to be the I proposition. Some monkeys are that which like bananas. Okay, so let's bring that up. That's the subalternate. Is the subalternate true? Yes, the subalternate is true if A is true. Okay? If A is false, then we don't have enough information to declare whether this is true or not. So truth flows, but falsity does not. Falsity doesn't flow. We don't know. Okay, so truth will flow down, falsity will not. Okay, and then we have sub-contraries. Okay, so they're between I and O. And so both can be true. Okay, it can be true that some lawyers are crooks, and it can be true that some lawyers are not crooks, but both cannot be false. So if one is false, the other has to be true. Okay, so both can be true, but if one is false, the other has to be true. They can't both be false. Okay, let's move on. This is the other thing I want to stress, is in logic, okay, if I was to say this normally to you, some students like scroll queen, generally you would infer from that, well, that means the opposite too. It means some students don't like it. Okay, but strictly in logic, it doesn't. We can only propose what it affirms as true. And here it's saying some students like scroll queen. If we look at the first one, we don't know what that says about students not liking scroll queen. We can only affirm what it says in the proposition. Okay, next one. Okay, so here's where we're getting to the crux of what we're going to be working on today. So we're going to try and use the square of opposition to see what it says about the three propositions that follow. So this is our claim. All chicken palmies are delicious. Okay, so universal agreement in the classroom here. What can we say about the following propositions? So we're starting with an A proposition. What can we say about these ones, A, B, C? So the way we're going to solve this problem, okay, I'm looking at that first one, I'm going, some chicken palmies are delicious. I'm going, where is that on the square of opposition? Some S is P. That's an I proposition, okay? It's an I proposition. And so we're assuming this is true. This is the claim we're given. And we know from sub-alternation, okay, I've written them up here, what applies to the universal, okay, so if the universal is true, also applies to the particular, okay? So if this is true, then the I statement is true, okay? So we're going to press the next button, we've got a true there next to it, okay? What about no chicken palmies are delicious? I'm looking at that, I'm going, what does that correspond with? That is an E statement, okay? No S is P. No chicken palmies are delicious. If this is true, this must be false because it's contrary. Okay? They could both be false, but if one is true, the other must be false. And then the last one, some chicken palmies are not delicious. That's our O, and they are contradictory to one another. So if this is true, this has to be false. Okay? It can be, like an easy way to do this is to go straight for which is the contradictory and fill that one in first. Because if you do that, then you can use that proposition as well to help you fill in the square of opposition. Okay, let's go on to the next slide. We have another example. This one's going to be a little bit trickier. Okay? Some teachers are smart. We're not assuming it's true. This time we're assuming it's false. We're saying this proposition is false. What can that tell us about the other propositions? So some teachers are smart is of this form. Some teachers are smart is of this form. Now we're assuming that is false. Okay? Now let's look at the proposition we've got here. No teachers are smart. That is an E proposition. So we have an I proposition and an E proposition. They're opposite, they're contradictory to one another. So if our claim here that some teachers are smart is false, then no teachers are smart has to be true. Okay, so that one's going to be true. True. Okay, then we have the proposition all teachers are smart. Okay, well if this is true, okay, if this is true, this has to be false. Okay, and then we have the last one is the O proposition. So look how connected this is. I've got two ways I can get to it. I know if this is true, that truth flows downwards. Okay, and the other one I know is if this is false, this one has to be true. Okay, so we've got truth flowing down to here, so this is true. And we've also got, if this is false, then its opposite must be true. And so we've got true. Okay, so we're going to go through this first problem together in our books. This is the first one we've got listed, and I'm going to show you how I want us to go through it. We won't do those tables above just yet, because that's probably where it will get a bit challenging, because there's not propositions to think about, you're just referring to the square. So we've already gone through, and we've already labelled them A, E, I, and O. And so now we're going to use the square of oppositions. Part A, what I would like you to do is draw these sort of columns up next to it. That's going to help us answer it, because given the propositions, in part A it says affirm the first proposition is true. What does it say about the rest? In part B, it says the first proposition is false. What does that say about the rest? Okay? So we're going to do this first one together, and then you'll be able to move into question 2, 3, 4, have a bit of a go at them yourself. Okay, so we're going to start with A. We're affirming this is true. A is true. So if A is true, what does it say about E? Okay, we've got our A proposition is true. What does it say about E? E must be false. They are contrary to one another. If one is true, the other is false. Okay, so we'll go down there. If A is true, E will be false. All right, and then next we've got our I proposition. Okay, if A is true, I must be true as well, because truth flows down our square of opposition. Okay, so if A is true, then I has to be true as well. And then the last one is our O proposition. Sum S is not P. Okay, so I would be looking like just straight across. If this is A and this is true, then this has to be false, because they contradict one another. Okay, so this proposition must be false. And so if we have the claim, all successful executives are intelligent people, we're saying that's true, look about the truth value we've discovered of all these other three propositions. Okay, so when you're thinking about truth, that's not too bad. But when you're asked to say the first statement is false, what does it say about the others? Okay, so if it's false, if A is false, and then this is how you can think about these, if A is false, then O must be true. So you can jump straight to that one. If A is false, O must be true, because they are contradictory. O must be true. Okay. But then let's think about the link between A and E. They are contrary. And so if one is true, the other is false. But so far we've only got one is false. And they can both be false. So we can't straight away affirm something if this is false. We don't really know what this is. Okay? And the other way to look at it is we've already affirmed, what have we affirmed? That this is true, sum S is not P. Okay, if A is false, then O has to be true. But we've said truth only flows downwards. It doesn't flow up from the particular to the universal. It only flows downwards. Okay, so we're going to put a big U here, because we can't affirm whether that is true or not based on the fact that this is false. All successful executives are intelligent people. Sorry, which one was I just talking about? I was talking about...
Yeah.
They can both be false. They can both be false. That's okay. Yep. Okay, then the next one. Some successful executives are intelligent people. So now we're talking about this proposition, the I proposition. Well, this is false, and I've said falsity doesn't flow. Okay, it doesn't flow. We know this is true. All right, but remember we've said both of the ones at the bottom could be true. Subcontraries can both be true. All right, and so that means, again, we don't have enough information to affirm whether this claim is true or false. Okay, we know this is false. It's false that all executives are intelligent people. But we don't know whether it's true or not that some are. Okay, just from this claim being false, we don't have enough evidence. The only one we can affirm, if this is false, then this has to be true. Okay? and then we don't know which way it goes, whether it applies to the whole group of, what are we talking about, executives, or whether it applies to only some of them. Okay, so again, you guys, fill in column A first. So a bit like I've done up there, maybe you can see how I've done it. You've got column A going down. Have a go at that first, because that's going to be a bit easier. We're assuming the truth of the proposition, and then in part B, we'll assume the falsity of it. Thank you.